Alright guys, so this is the semester exam review. We're gonna go over the reviews since we don't have much time during class. So let's get ready and just pull out your review and we're gonna go over this thing together. Okay, number one. So it says explain the difference between analog and digital electronics. So basically analog is continuous. If you remember, basic analog looks like something like this, so it's continuous, and the digital is basically a rise and then down, and so it goes up and down like this. So whenever it goes up, it's a 1. Whenever it goes down, it's a 0. Okay, so number two, what is the definition of electricity? It's basically electricity. Remember, if you plug, it's basically a flow of electrons. Okay. So the electricity happens because when there's electrons flowing through, the device is powered up. Number three, what device is used to make electricity? It's a generator. Okay, or you can say a battery. But if you see on test, you see generator, go ahead and select that. Number four, electricity is really a blank and blank transfer energy. Okay, so we're gonna put cheap, fast, and clean. Okay. Number five. Something is any device that turns one form of energy to another, and that is going to be transducer. Okay, number six, you should know this. You know what makes a light bulb shine? Basically, we need sources. Okay, we need a source, and also need a low and a pathway, meaning the wires. Okay. Number seven, electrons flow from negative to positive through a low, and work gets done in a blank loop circuit. So basically it's saying electrons will only go through when you have a circuit. So for example, you have the battery. Okay, the electrons will only flow through and goes through a resistor. Let's say this is a light bulb. So electrons will only go through when the circuit is connected, right? So right now that's called open circuit. Only if you connect it to, make everything connected, and that's called a closed circuit loop. So that's only so electrons will flow through from negative to positive, and work gets done in a closed loop circuit. Okay. Number eight, the pattern is basically opposite. There's no one gets done in an open loop circuit. Okay, so number 7 is closed, number 8 is open. Number 9, a blank is used to open and close a circuit. This should be fairly easy. That it's a switch. Okay. Number 10, electrons move from negative terminal to blank terminal to blank terminal. So I already said the answer earlier. This goes from negative to positive. Okay, number 11, electrons carry a negative charge. Okay. Okay, I'm not really going to go into detail to explain that. Okay, number 13, engineers talk of blank current flow from the positive terminal to the negative terminal, even though in practice, due to negative charge, electrons flow the other way. So I'm not sure if you remember at the beginning of the semester, I talked about how electrons flow through from the from negative to positive, from positive to negative, but in reality, it should be positive. So for number 13, it should be positive. Okay, number 14, current flowing in only one direction is called direct current, okay, DC. And current, number 15, current that is constantly changing amplitude and polarity is called alternating. It's called alternating current. Okay. Number 6, definition of voltage is basically the pressure or the potential difference in charge or push of electrons. So it's basically the push, okay? It's the force that moves the electrons. Number 17, the unit of voltage measured in is volts. Okay. Number 18, you can go ahead and skip that. That's not going to be on the test. Number 19, what is amperage? Amperage is basically current or the amount of time. Okay, the amperage is amount per time of flow of electrons. Number 13, we kind of briefly talk about it, but it takes about 0.5 amp to actually kill a human. Number 24, what is resistance? If you remember, resistance is basically the opposition to flow of electrons. It's basically resisting the electrons from going through. Okay. Number 5, what is resistance measured in? If you remember, the unit of resistor is ohms. Okay. It's ohms. That's number 24. Okay, number 25. Resistance and amperage are blank proportional. So basically, if you remember, when the resistance goes up, the amperage goes down. So that's called inverse relationship proportional. Well, actually, inversely. Okay. Number 26, voltage and amperage are blank proportional. So basically, if the voltage goes up, the amperage should also go up. So we're gonna put directly. Okay. Number 7, Kirchhoff's voltage law states in a closed loop circuit, the sum of all voltage is equal to blank. In other words, the sum of sources is equal to the sum of voltage drops. Okay, so that's basically saying, if you remember, if it's a closed loop, the voltage law, so the first blank should be 0, and the second blank is equal. Okay, number 30. The Kirchhoff voltage law basically is the following: R1 plus R2 plus R3 equal to R total for series circuit. I total is I. In a series circuit, the current is the same for every resistor. There's the example later on, and we'll go over that. And voltage is V1 plus V2 plus V3. Okay? Go ahead and skip 31 and 29. Actually, I don't really like the two questions, so go ahead and just get rid of it. For the parallel circuit, okay, once again, there's an example later, but you can go ahead, just write down the equation. So if you remember, to get the total resistance for a parallel circuit, there's that one weird equation that's like 1 over blah blah blah. So to get the I1 divided by R total is going to be 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. But if we want to get the R total, then we would if we want the R total, because if you pay attention, it's right there, it says 1 divided by R total. But if we actually want R total, we just kind of flip the flip it over, so it'd be 1 divided by everything that's inside. So that's how you get the R total. And for a parallel circuit, since the voltage, you know, if you remember, voltage is the same throughout the circuit. Okay, if the voltage is the same and the resistors are different, then the current should be different, right? So to get the I total, you just gotta add up all the currents together. Okay, so number 31, because current is the same in series circuit, when leaving a measuring current, ammeter is attached in series to the component whose current being measured. So basically that's saying, let's say we have a series circuit. Here's a battery. Okay, there's 2 resistors. There's 1 battery. Okay, to get the current, all you gotta do is first you break the wire, okay, and then you bring in, let's say this is the ammeter. Ammeter is the device that tells you what the current is, okay, and then it has a 1 black wire and a 1 red wire. All you gotta do is connect the 2. You just kind of put it in between the circuit, and that's how it. And then it give you a reading of current. So that's what's basically what that question is asking. Okay, number 34. It's asking if since voltage. Let's say I'm going to draw a parallel circuit. Okay. So once again, parallel circuit. There's multiple paths. Okay. All right. So because the voltage is the same, so that's voltage 1. Is the same thing as V2, V3. They all have the same voltage. So to get that, we want to know what the voltage here. So I'm going to bring the voltmeter again. Okay, it gives it a reading. So all you gotta do is connect the wire through here and connect the other wire through here. So that will give you a reading. So for this blank right here, it should be voltmeter is attached in parallel to the component. Okay. Okay, number 33. Okay, here's the example. Here's the example of that problem. Okay. Alright, so once again, so first of all, this is a series circuit, right? And the voltage is 120 volts. Resistors are 50, 40, 100, and 50. So first of all, we can know the first step you should always find the R total. So if you see the R total says here, it says to get R total, all you gotta do is add them up. So 50 plus 40 plus 100 plus 50. So 50 plus R total equal to 50 plus 40 plus 100 plus 50. So we can know for sure our total is 240 ohms. Okay? Because we can always solve for the R total when we have a series circuit. So the rest, and then we can find the R total, right? So to find the current, you should know the equation by heart is V divided by R. So our voltage is 120, our resistance is 240, and it should give you 0.5. Okay, that's your I total. Alright, since this is a series circuit, then we know the current is the same. So I1 equal to I2 equal to I3 equal to I4. So that's saying the current right here is 0.5 amp. So the current here and here and here are all the same. Alright, so we're pretty much done. Only we have the voltages left. So to control the voltage for each resistor, you should also know the equation by heart is V equal to I times R. Since the current is 0.5 times 50, that gets you about 10, 5, 5, 5, 25. Okay, so you should give you about 25 volts here. And all you just got to do the same thing. So current half times 40, 0.5 times 100, 0.5 amp times 50 ohms. So you should find the voltage like that. Okay, really simple. All right, number 34. First of all, this is parallel circuit, right? So you should know by heart that the voltage here, here, all the same. So this should be all 12 volts. Okay, 12 volts everywhere. Okay. Since the resistors are given, then what can we solve for? Can we solve for the current then? Right? So it's 12 here. So for I1, it's just 12 divided by 24. For the second one is 12. This one right here, 12 divided by 80. Okay, excuse my writing. So you should know the deal by now. So it'd be 12 divided by 60, and this is the third one. Okay. Then right away, really quick, you can already find the voltage. You can shift out the voltage 12, and the current is what you get by dividing voltage by resistor. Okay, number 35, that pretty much the same thing as what we did earlier. The total resistance of the circuit, all you gotta do is 3 plus 12 plus 5 plus 5 again, so that should give you about 5 times 10, 23, 22, 23, so the number should be D. So the current that goes through it, so the next one, what's the current that's going to go through R3? So once again, once we have the current total resistance, it would be 25, right? So the current, it would be 10 divided by 25. Okay, so whatever you get from that, that should be your answer for the next one. Voltage used by R2, since we already got the current here, because the current is the same everywhere, and to get the voltage, we just gotta times the current times 12 ohms. So whatever you get from that. Next one, voltage used R4. Okay, so we have the current. We already know the current. Then we can multiply the resistance of R4. Okay, so it's easy. Okay, next one. What's the total resistance of the circuit? Once again, okay, so for this one it's a little different. Let's just skip that for now. So first of all, what's the voltage across R2? Our voltage here, right here, is 12 volts, so that means R2 is also 12 volts. Okay, what is the current that goes through R1? So for R1, we know the voltage is also 12 volts. So 12 volts divided by 24, you get half amp. So 0.5, but if you reduce to milliamp, it would be this one. Okay. Current that goes through it, same thing, 12 volts divided by 80. So whatever you get over there is all that you need. Okay, for the total resistance, if you remember carefully, if you remember clearly, it just follow this equation. 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3 plus 1 divided by R4. Okay, excuse my writing, but so just follow that equation, then you should be able to find the total resistance. Okay, that's the same thing over here. Same problem on that one, on the one above we just did. So I'm not going to go over that because once again, this is parallel circuit. So just know that voltage is the same everywhere. And to get a current, you just multiply voltage, divide by voltage, do voltage divided by resistance. Okay, number 38. What controls the flow of current? So if you remember careful, that's clearly that's a resistor. So a resistor controls the flow of current. Okay, 39. Draw a systematic symbol of a resistor. It basically looks like a spring, something like that. We'll just do fine. 40. Most resistors are made out of blank and insulator mixed with binding material. So the answer for number 40 is carbon. Okay, they're made out of carbons. Okay, number 41. Okay, the top one is lead. Okay, second one is first digit, second digit, multiplier. Remember, whatever the value is, you multiply that number. Okay, somehow the R is not coming out. Okay, the last one is the tolerance. Remember 5% or 10%. Okay. All right, 42. Gold means 5%. Silver means 10. None means 20. Okay. 43. I'm not going to go over this. You should be able to do it yourself, or you can Google it yourself. 44. I'm just going to go over a few, maybe two of them. Okay, so the first one, brown, it means 1 because that's what the chart says. Black is 0. Brown is 0 again because it's 10. So 10 times 10 is 100. And since it's silver, it will be plus or minus 10%. Okay, I'm just going to do one. Okay, number 45, a battery is a can full of chemical that produce a blank reaction, a slow but constant discharge. So some of you asked me if it's chemical reaction, but to be exact, it should be electrochemical, because electro means electricity, chemical means chemistry. So it's actually produce an electrochemical reaction. Okay, next one, capacitor. We use capacitors to store large amount of electrostatic energy used to prevent or reduce changes in circuit voltage, deliver smooth voltage through a circuit. Okay, number 47, blank is a property of an electrical device that allows it to store an electrical charge, and the answer is capacitance. Remember capacitor? But this one's capacitance. It stores the electrical energy and then it releases it right away. Number 48, why are capacitors potentially dangerous? Because they discharge all their charge all at once, because it could be really dangerous. Just like a lightning, it releases all the energy at once. Okay, 49. When an electron moves from its valence ring, it leaves behind an electron. And let's skip that one. Okay, we didn't really cover it. Okay, number 49. I ask you to draw symbols for following capacitors. So the first one, fixed non-polarized, looks like something like this. So that's how a capacitor looks like. Fixed polarized looks something like this, okay, with the plus. And the last one, variable, looks like that. So just kind of know what it looks like, okay. Let's skip number 50. Okay, for 51. The three main factors that affect how fast the capacitor discharges are surface area of the plates, distance between the plates, and the dielectric. Okay. Number 51. or your 52. Okay, Coulomb is the international standard unit of electrical charge. His name is named after a person. His last name is a Coulomb. Okay, 51. 1 Coulomb is what we just wrote. 1 Coulomb is the amount of energy let's skip that one too, since we didn't really cover it. Okay, next one. Capacitance is measured in farad. So number 54, 1 farad is the amount of capacitance for which the potential difference of 1 volt results in static of 1 coulomb. Blah 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 blah. Number 55, AOI and or inverter. Okay, this one you should already be familiar with it. There's an AND gate or inverter. Okay, gate symbol. AND gate looks like this. OR gate looks like something like this. Inverter gate looks like a triangle with a circle. Okay? And truth table, you should know this by now. So basically 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1. So for AND gate, it only gives you 1 when both inputs are 1. OR gate, it's basically as long as you have 1, 1, it will have a 1. NOT gate is just converts, it just makes it opposite. 0, 1, 1, 0. Okay. Number 57, we covered this a while back, but it's basically asks you to fill out the truth table and by counting in binary. So it's basically we're counting in binary 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So to do that, it's the same thing as setting up a truth table. Okay, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 1, 1, 1, 1, 1. If you remember doing this, just setting up the truth table, okay? Everything else is 0. Okay, so that's how you count. So 0, 0, 0 is 0. 0, 0, 1 is 1. 0, 0, 1, 0 is 2. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so if you remember, so the D represents 2 to the 0. What is 2 to the 0? It's always 1, right? Now this is 2 to the 1, which is equal to 2. Okay, this one is 2 to the 2. Second power is 4. A is 2 to the third power equals to 8. And so this one equal to 1. So if you look, once again, so this one, 0, 0, 0, 1, so this one, 1 times 1 is 1. And then 1 times 2 is 2. And then 1 times 2 and 1 times 1, so 2 plus 1 is 3. So you see how it's 0, 1, 2, 3, 4? See that 1 times 4 is 4. And 1 times 4 plus 1 times 1, 4 times plus 1 equals to 5. Okay? Okay, number 58 is basically asking you to create this truth table for this little coffee maker project, okay? So it says the coffee machine that has a light on all the time, asking for the user to select a coffee size. Okay, the light turns off when the user presses only one of the 3 switches. The switches are small, medium, and large. So small, medium, or large are your choices. And light is your light is the output. Basically, once again, like what it says, so the light is always on when when the nothing is pressed, right? So let's fill out the truth table. 0, 0, 1, 0, 1, 0, 1, 1, 1, 0, 0, 1, 1, 1, 1, 1. Oh, okay, I'm just filling out the truth table. Everything here is 0. Okay. So when nothing is pressed, meaning they're all 0, so light is on, because here's what it says: the light is on when light is on when it's asking what size does the user want. Okay, so the large is pressed, so the light turns off. So okay, wait 1 second. Okay, so this one should be 1, because it says the light will turn off when the user presses only 1. Okay, and you see this one, there's two inputs pressed, so it's gonna still be on. 1, wait, 0, the light's gonna be off. This is gonna be on. 1, 1, because all the switches be on. Okay. All right, by doing this, then you can write out the expression. Once again, we only care about the output when the output is 1. So SML plus SML plus SML. Okay, there's 2 of them, 2 more. And whenever the inputs are 0, we're going to put a line on top. Okay, in this case, I am going to use underline. Okay, so the next one, the S has a line on top, and then the next one is M. The next one is L. Okay, so that's your final equation that represent this circuit. Okay. 59. It's basically asking you to draw this, basically. Okay, I'm gonna draw it for you. Okay. First of all, you know that how many switches you got? 3, right? Because it's SML, S, M, L. Okay. Okay, and then you see like they're all different. So I'm gonna set it up with a NOT gate for each input. Okay, set it up. Okay, I'm gonna draw this equation right here. So first of all, I know usually we do 2 input AND gates, but this time to make it easier, I'm gonna use 3 input AND gates. Okay, so I'm gonna put an AND gate here. SML, they're all lines, so I'm gonna connect it to all the NOT gates. Okay, that's the first one. Second one, the S is knotted. Oh, I'm gonna use a different color. Okay, that's one. And everything ML, they're all positive. Okay. Okay, third one, S, not M, L. Okay, you get the idea. Okay, I'm just going to draw 3. So, and then you see these 3 are connected by what? By the plus sign, right? Then you should know what kind of gate you should use. So for plus, I'm going to use OR gate. Okay, once again, I'm going to use 3 input OR gate. So this should be it. Okay, I didn't draw the rest of the 2. If the equation looked like this, that's how it looked like. Okay. Alright, number 60. This is just asking you to label the pin numbers. So if you remember looking at those data sheets of these gates, these chips, it has a dimple right here, right? So make sure you remember this is where the ground goes. So this is where the sum 7 is, okay? This is where the G and D goes, and this is your VCC. VCC is always number 14, and ground is number 7. So like the rest of them is 1, 2, 3, 4, 5, 6, 7, and set 13, 12, 1, 11, 10, 9, 8. Okay. Once again, I have 14 legs. So that should be the last hour review. So hope you get to use this and review on your final. So the final will be much easier than this. So if you can get through this, then the final will be super easy for you. Okay. All right. Study hard. All right. Bye.